Tom Gruber is the co-founder and head of advanced development of Siri at Apple's intelligent personal assistant. He was also the co-founder of realtravel.com, co-founder and CTO of Introspect Software, and a research scientist at the Stanford University Knowledge Systems Laboratory. Rao Kambhampati is a professor of computer science at Arizona State, and he's the current president of the Association for the Advancement of Artificial Intelligence, known as the AAAI. And Francesca Rossi is a distinguished research scientist at IBM T.J. Watson Research Center and a professor of computer science at the University of Padova. She's also the editor-in-chief of the Journal of Artificial Intelligence Research and a member of the World Economic Forum's Global Council on AI and Robotics. Our moderator tonight is John Markoff, the Pulitzer Prize-winning journalist and author. He joined the Computer History Museum as its historian in January of this year. And prior to joining the museum, he was a business and technology writer for the New York Times for nearly 30 years. And if you've been around long enough, you read his earlier work in InfoWorld, Byte, and elsewhere. Please join me in welcoming to the stage Tom Gruber, Rao Kambhampati, and Francesca Rossi, and John Markoff. Thank you all very much. Have fun. Good. Have fun. Good.
So believe it or not, it's been 50 years since Dustin Hoffman appeared in the movie The Graduate, half a century. And if you remember, there was this one scene where Dustin Hoffman is this alienated recent college graduate, and a family friend sort of accosts him at a party and says, "I have one word for you, plastics." You all know that if this movie was remade today, there would be two words, and they would be machine learning. Machine learning is everywhere in this world, and it's the relatively sudden success of AI has both created a great deal of anxiety, but in fact, these periods of anxiety about automation and AI have happened with great regularity about every 15 years, going back to the dawn of computing. And we're clearly back in that kind of a situation, but the sense is this time it's different. This time it's real. And that's touched off this debate. There are statements of great alarm from industry experts, and it's also, in turn, focused the attention on people like these who design these systems. And so tonight we're going to focus on the process of designing these systems and also the consequences of basically sort of deploying these systems at great scale, a societal scale, what it means. I just wanted to note before we get started, 1962, dawn of interactive computing, right around Stanford, equidistant from Stanford. In the same year, there were two laboratories that were created. John McCarthy, who was the father of AI, created the Stanford Artificial Intelligence Laboratory. He basically set out to replace the human being. He thought it would take a decade at that point to build a working AI. On the other side of campus, just as far away, was Doug Engelbart's lab, the father of the mouse. Engelbart set out to use the same technology to extend human intelligence. He called it, in that first paper in '62, IA, intelligence augmentation. So you have this dichotomy, AI versus IA. And we'll talk about that, but I wanted to sort of get us started on a more personal, from a more personal perspective. When I was reporting for a book I wrote recently called Machines of Loving Grace, I was struck by how many scientists and engineers had actually entered the field of artificial intelligence after they saw the movie Space Odyssey, and they decided that they wanted to build HAL. And that's probably a lot of deep questions that we could explore, but that's not what we're going to do. I mean, Rod Brooks, who was a Stanford Sale graduate, and Jerry Kaplan, who was a postdoc here, both went into the field of AI because they wanted to build HAL. So that brings us to our panelists. And I wanted to start by asking each of you, what brought you to the field of AI? Can we start with Tom? Why did you decide to pursue artificial intelligence?
I was a psych major. I wasn't even a real scientist, but I wanted to. But I was interested in the mind, human mind, and I read a piece by Raj Reddy about his first speech systems, Hearsay 2, in which he talked about actually representing knowledge, and that just got my attention. So that got me into it. And then a few years later, as I got into graduate school, I built my first AI system, which was about how to give communication prosthesis, how to enable, say, a cerebral palsy patient to be able to speak, who is otherwise unable to speak, using all of the things that computers can do if you give them AI. So understanding intent, being able to generate speech, and things like interacting, so that's how I got into it, because I saw this idea that you could build a human mind, but you could use it to extend a human being. And it was very much in the sense of the...
But from the very start, you were thinking about building a human mind.
Yeah, yeah. But not in isolation, that's the key thing. It was both. In some sense, Raj was already there too.
Yeah.
Augmenting human beings with his representation.
Francesca, what brought you to the field of AI?
So for me, it was not Space Odyssey. It was Star Trek. I loved the series. I watch it all the time. And that was my idea of, making machines intelligent and helping humans explore. In that case, it was space exploration, but I mean, it was discovering, explorations of what is around us. Yeah. So that was my, imagination.
How old were you when you, were you before, was this before college?
Yeah, okay. Yeah, before college, yeah. Anyway, yes.
Yeah, so I have a much more geekier explanation. I'm an electrical engineering major, and I was doing speech recognition, and I realized you can't just do signal processing to understand speech. And really, much of doing anything in speech recognition or natural language involves understanding intelligence, understanding human intelligence, and trying to, figure out how individual pieces of what we call intelligence actually connect to each other. So that was my interest in AI. It actually helps that in those days, Pat Winston's book could be read in a summer because it had no equations and it was all text.
So this is mid-'80s?
This was, yeah. Are we supposed to tell all that stuff now?
Yeah,
but anyway,
yeah.
So I think it was, this more overarching view of intelligence as again as just work on specific signal processing projects. That's what got me there.
So we're going to try an experiment here. I want to ask you guys to react. Ed Feigenbaum was a member of sort of the second generation of AI pioneers, and I think Ed is here today. There's Ed. He was a student of the pioneers, and then he came here to Stanford and worked with people like Tom. But we have a video that I want to play of Ed sort of framing the problem that I think faces you guys. So I'd like to play the video and then ask you guys to react to the way he framed this challenge.
We have excellent examples of intelligence walking around us all the time. They're easy to study. There are billions of them to study. And we, as scientists, in my view, at least for myself, and I'm pretty sure it holds for most of AI, we're better at discovering things than we are at inventing things. Inventing is hard. Finding mechanisms by discovery, looking at complex human behavior and modeling that behavior is easier.
So you guys are designers and you're scientists. How do you frame, is that still the way you frame the problem? Francesca, let me ask you first.
So, this is true that for humans, of course, it's easier to discover than to invent. And I think that for machines as well. So when we design intelligent machines, I think that it makes sense to observe human behavior, to gather insight and to discover patterns that you can then use to build a model of this human behavior, and so that the machine can follow that model when functioning. But I still think that if you want humans and machines to work together and cooperate, be a team, which is what I think we should do with AI, IA, rather than AI, then I think that still there is a lot the machines can do in discovering, and humans can focus also on inventions.
So I actually think that AI as a whole, as you pointed out yourself, had a somewhat of complex relation with humans. I keep thinking of John Lennon's quote that you want to help humanity, it's the humans that you can't stand. And so part of it was, and in some sense, all the great examples of AI involve, being on Mars or being completely autonomous. I think in the beginnings, people were worried about directly going with humans because there was just too much of a scope for presumably cheating. So, the original mechanical Turk had an actual Turk inside that machine, for example. And so I think that was one of the things that probably, kind of pushed the field away from these deep connections to psychology, deep connections to philosophy, and so on. But I think it's coming back because I think AI right now, we don't have to worry that we would be cheating by having humans in the loop. In fact, the enterprise of AI is going to be much more interesting because you have to deal with humans and you have to deal with their behaviors as well as get the machine to show the kinds of behaviors that humans expect. And so I think that would be coming back more, actually.
Tom, the dichotomy?
Well, we can talk afterwards with this is what you really mean, Ed, but I think this is what you mean. I think you mean two things. One is that the very thing that makes machine learning great today is that it's imitating people at scale. So every few days, 1 billion people's voices flows through the servers of Siri, and it hears the voices. That allows us to understand how it sounds for people in 36 languages to say things. And that gives us a handle on how human language works. Now, it used to be, in the good old bad days, whatever, that people would hire a bunch of linguists and so on, and they would tell us how language worked. That's the other way of learning from humans. But learning from large numbers of humans at scale is how machine learning does it right now. And so that is the secret, and it's if you don't have a lot of data about what the right answer is at scale, you can't do the machine learning piece. The second sense, I think, is also interesting. Almost every time I see interesting AI today, it's a collaboration between a human and a computer. And if the collaboration isn't designed in a way that accounts for the different cognitive abilities of the machine and the human, it fails. We just talked with Gary Kasparov recently, and he was talking about the case that after Deep Blue won the match against him and so on, there was a bunch of time in which no one actually was playing games. And then finally they had a freestyle game where they had said you can bring any computer you want, and you can bring any grandmaster you want. So the grandmasters got sponsored, and they had giant, huge, big iron machines, and they lost. The ones who won had 3 IBM PCs with Pentiums in them or something, and they were nobodies who'd hardly even play chess. But they had the best interface.
Yeah.
They could work with their computers better than the grandmasters and the supercomputer. So I think that's really the sweet spot now, is to do machine learning to understand how people work, and then make that machine understand how humans work.
We'll come back to that, but before we go too far, you guys are all board members so why are we here? You're all board members on this new organization called Partnership for AI. Could you briefly sort of give us a high-level explanation of why this organization and why now? Would one of you take a cut at?
Francesca? I think
Yeah,
you've been...
sure. So the idea of this initiative, Partnership on AI, came from researchers, okay, who were, meeting at various, events where we were trying to understand what the issues are in the impact of AI and the pervasive use of AI in our everyday life. And we thought that it would have been good to address these challenges and issues together, even among companies that compete on the marketplace. Because competition is fine, but around these issues, we thought that really a collaborative environment was the best way to go. And not just among companies, but also to open up to all these stakeholders around AI, all the, policy-making people and even the public, the civil society, the scientific organization, everything. Only by talking all together and discussing these various issues and understanding the issues, then we can address them. Of course, the companies have a big role there because the companies are there to deploy AI into the real world, so they really know the issues much better of when AI is deployed and used in the real world. But once they bring up the issue, then the discussion has to be open to everybody.
So I've heard that in addition to sort of creating what you call best practices, you're talking about proposing grand challenges. Is it possible that you will sort of try to direct the technology by, what might a grand challenge, what a non-DARPA grand challenge that comes from industry, what might it look like?
Yeah, I mean, we have several mechanisms in mind to, make a concrete step forward in addressing these issues. Grand challenges is one of them, and we still have to define them, but I mean, we are working and brainstorming about them, or there will be white papers, there will be guidelines, principles, and you name it. I mean, we still are thinking about them, and Rao and Tom can say more about it. But I think that we are going to focus on various themes and on various sectors like transportations, healthcare, or others, and themes like like ethical behavior of AI systems, or data bias and data issues, and or algorithm accountability and explanations, all these themes and sectors, together with all the partners. At the beginning, the founding partners are just 6 companies, but then even by now, I mean, more than 30 partners are in the partnership on AI.
Would either of you like to?
So yeah, I think that's the key to it, is that there's no competitive advantage to any of the things that we do. We all basically want ethical AI. We want to do human good with it. We want to make sure it's safe. We want to make sure that those who participate in advancing, and by the way, it's like you said, a research-led. It's not marketing or whatever. It's like the researchers who do the AI want this technology to be used correctly and well. And so that's really the essence of this.
So how much of a struggle was it to convince the people who run the company to buy into this?
So that's sort of the kind of the interesting thing. I guess 10, 15 years back, if you started talking about we want to think of AI's impacts on society, I guess AAAI, that organization I represent, was doing it in workshops and so on, but mostly people thought of it as presumptuous on our part to even think that we'll have an impact on the world. But right now, essentially, everybody is actually, I mean, if you just keep up with New York Times or anything, everybody is convinced that AI is going to take over, and it's basically the most important technology. And people, the companies were just as interested in sort of getting a discussion in, about best practices. So one of the things that we found, as Francesca said, was when we opened the second round of memberships, the number of companies who wanted to join, and some of them wanted to join like right away just to be part of the discussions on some of these very complex questions on privacy issues and how the data is being used and safety issues and so on. Each company was pretty much sort of doing it on their own sort of best understanding. It could be something that in a room full of representatives you could actually have a better discussion about. And so there was a lot of interest. So it wasn't hard to convince people. If anything, in fact, we're being asked to start the third round of entries sooner than later. So that's actually the kind of thing.
But to respond to John's questions, I mean, in IBM, it was very easy to convince the whole company, starting from the top level. And I think that in the other companies also, it was very easy. I don't think we encountered any, problem convincing that was the way to go.
Yeah. There was always this notion in the back of my head is that, well, the industry is being proactive here, but they're being proactive because they're really afraid of the possibility of regulation. And in fact, it's very real. It's actually real in both the United States and Europe. Europe, of course, is well on the path to regulation. In the United States, if you look at self-driving cars, which are robots, we're about to regulate them too. So regulation is there. Yeah, and in fact, one of the main goals of the partnership is also a very big educational effort, because for policymakers to develop the right regulations at the right time on the right objects, research or deployment or uses or whatever, they need to know exactly where AI is right now and what the limitations are, what the challenges are. Because if they don't know exactly, then they could deliver regulations that do not make much sense.
So I think that, again, I mean, there's a certain electric car manufacturer who has been saying AI should be regulated like right away. The question is, what do you regulate? Even having an understanding of what are the parameters is something that's not actually feasible right now. And so I think a non-cynical view of this is that these kinds of discussions would, I mean, even if companies join this to get ahead of the curve on the regulation, at least the discussion would inform, because currently, other than one very interesting initiative in Obama administration, there hasn't been that much from the government in trying to understand, what the issues are and what are the regulatory aspects of it. So I think there's a lot of groundwork that needs to be done, and that can actually be done in organizations like the AI.
What about the specific situation, I think, in the European Union right now? There will be a regulation that makes you design algorithms that can, well, the algorithms must explain themselves in regulatory climate. My sense is that's not really technically possible with today's deep learning machine algorithms.
I mean, of course, it depends what they mean by a meaningful explanation, which, for example, it cannot be like the source code and the data. That's not a meaningful explanation for anybody. But certainly, by May 2018, every European state must put, can use only systems that, if they make decision about people's life, they have to explain that decision. Like if you don't get a mortgage, or because of some automated decision, then you have the right to get an explanation.
Okay, I mean, are there real world examples right now of building ethics into systems? Can any of you cite, design processes where you've had to do it already? Do they exist?
Well, the machines don't make moral choices today, really. It's the system that creates the system that you want to create for ethical things. So take an example. This is hypothetical, but I think it's kind of analogous to something real. Let's say you're trying to build an AI system to prevent people from making optimal decisions about recidivism and parole. So you say, this is a hard decision, it has societal impact and so on. So you do it, and you get a bunch of data, and you see the outcomes. Well, this judge said he stays, and then this judge he says doesn't. There's a way of measuring outcome. Well, it turns out that if you just do it that way, you're going to make a system that discriminates against African Americans, okay? Not because the data, or they selected the biased data in some way, or not because the scientists are biased or anything else. It's because the system that creates the data is already biased towards dragging people of African American descent into these systems. And therefore, they're just touching the system more, and they're creating more data points, which causes this whole thing to happen. So it's an interesting thing. I think almost all the cases, we have to think about the meta or the embedded system that the AI is living in. Autonomy is the same way. All these decisions are being embedded in larger systems.
Yeah. Well, but so maybe Tom, if you'd be comfortable talking about this, I think about the role of so since this effort came from the bottom up, it came from individual technologists who do design within corporations. The purpose of these corporations is to make profit for their shareholders. And so I could easily see a disconnect where the values of the individual designers might be at loggerheads with the profit-making nature of the company. I mean, I think this is, I know it's public, Tom. You had a sort of a put your badge on the table moment inside Apple around the design of Siri over whether a feature was going to be added. I
don't want to go into anything specific, but yes, we actually care a lot about the ethical use of these things, and we wanted to do good with it. That's the main thing. So we wanted to make it accessible and safe. There wasn't anything about, I think that was the wrong story. But there's nothing about the badge on the table about doing this. But I made a lot of effort to try to make sure that it was useful to make it safe in the car, for instance, and it was accessible by all people of all abilities.
Hands-free being a feature.
That was really important. Now, that was totally, the good news, is one of the reasons that I like working where I am, is because the alignment of the business model, again, the system, not individuals, the system of the business model of making money by selling hardware and vertical systems means that you're aligned with the delight and surprise of the users. And that business model allows for all the employees to be aligned about making those people making the users happy with the product, making them having ethical uses of it, safe uses of it, and so on. And other business models, like, say, give away free software in exchange for attention, also have benefits when those things are aligned so that the meritocracy of product design is aligned with profit. And that's what we want to be. We want to kind of, I think that partnership is also about not designing companies, but designing ways in which to do AI, like a grand challenge that would say, let's create a grand challenge that so as all companies participate in the grand challenge, the collective result that's created benefits everybody. It isn't a competitive thing. And that's the kind of thing we're trying to be creative about in this partnership.
So it's also the case that I think it's not so much that anybody in any companies are being sort of deliberately unethical. Most of the time, as Tom was pointing out, the point that you made about machine learning technology, most of it is essentially about the data that's currently available. So if I go onto Google right now and say, show me pictures of professors, most of the top 100 results will be white males. Is that because Google is actually being sort of, trying to perpetuate some biases? It's just the current snapshot of the society. And when you start making decisions about where the society should be based on the current snapshot without enough thinking, you will get things like Samsung camera, which would keep saying that all Asians were blinking. Now, Samsung is an Asian company. They are not being racist about Asians. It's just that they learned from the pictures of, I guess, the Westerners. And then they basically, so it's like it's easy to be inadvertently perpetuating biases. It's not that the machines are biased. It's not that the algorithms are biased. It's the data that's out there, and the data is easily available. It's the current snapshot of where we are. And it's a pretty interesting, tricky problem as to how do you train a system about where the society should be as against where the society is. And to some extent, I think that also goes back to your point about explanations. One of the things that has been a great power right now has been this thing that you call about deep learning. They learn their own representations at most of the time from the data that have been given. And so even if they explain, there's this Wittgenstein quote that even if a lion were to speak, you won't understand. So even if a deep learning system were to speak, you won't understand because you are not actually have much of a common knowledge. And that's a good thing as well as a bad thing. And it's going to be an interesting technical challenge.
So at some point, there will be a deep learning system in court. So what's going to happen at that point?
That's a very interesting question. So in fact, some people actually some of my colleagues, who work in Facebook, for example, say, people don't need explanations. People don't need explanations when you tell them, look at this, particular mail or look at this particular advertisement. But in judicial systems, we do believe that there should be explanations.
Or healthcare.
And it'll be very, very interesting to see how, unless you overlay on top of it some knowledge representations that we use, we're going to have major trouble in figuring out, So currently, for example, the kind of what goes for explanation in visual systems is to put a little box around like the thing that you think is the dog. So imagine putting a box on like an abstract, tube of reasoning saying, Your Honor, I say this guy is guilty because of this particular tube thing, and that's not the way we explain. Yeah. So it's going to be an interesting technical and research challenges.
There might be new ways of doing explanations that AI has come up with, because I have a friend who did AI in law, a colleague in grad school, and as he built expert systems to model the way people do legal reasoning, he quickly found out that the rationalizations that people make have nothing to do with the reasoning. And that's not just cynicism, it was just the normal practice of law. And so there's an art to creating a rationalization and explanation that happens after the decision most of the time. And as a cognitive scientist, I'll vouch for that's in everyday life, that happens all the time. We decide, then we think. Rationalize. So it might be that we could imagine AI systems that create a kind of civil discourse about what counts as a good reason.
Also good.
And so if it makes a decision, we can say, we believe that decisions should be made with this kind of rationalization. And build systems that embody those principles.
Yeah, and I think that AI can actually give, as the promise of helping, of being even more able to build explanation for machines, but also for humans, to make them more ethical than they are right now, because less biased than they are right now, because you could understand maybe the rationale and identify the evidence on which some decision making is based, maybe better on machines than in a human brain.
So you talked about courts. Let's think of like a medical, practitioner, a doctor who comes up with a diagnosis. When you go into the hospital, they are trying to explain their diagnosis to their peers, to the other doctors versus you. They're completely different explanations.
Yeah.
One of the big things is explanation is really not about your mind. You're not talking to yourself. You're talking to the other person. Yeah. And a hallmark of intelligence is essentially modeling each other and figuring out what explanation would make sense to you at the level you are in. And that's a whole direction, explanations beyond soliloquy, so that, in fact, you can actually do the right kind of explanations for the person based on their knowledge. And, that's something we have to go to. Until now, I think much of explanations have been sort of debugging explanations.
Yeah.
That is, if you wrote the program and it makes a mistake, it will try to explain, that explanation might tell you how to trace it. Imagine giving that sort of a thing in normal, like in a medical scenarios or a judicial scenarios. And so I think, again, these are beautiful technical problems that come up, and they're connected to the way humans deal with each other. In fact, I mean, there's this whole thing that we needed the huge brains we have not to run away from the tigers of the savannah. That's where we all came from, by the way. But to deal with each other, but to essentially model each other's mental models. And I think AI hasn't gone there. AI is extremely good at dealing with Mars, not very good at dealing with us. Mm-hmm. And I think it's actually a challenge. It, in fact, expands the scope and richness of AI when we can have systems build models of the humans that they're interacting with.
So I want to pursue the notion of the responsibility of the individual designer within the corporate construct a little bit farther. I think both Microsoft and IBM's CEO are on record as calling your companies IA companies, that not AI companies, but IA companies. And yet, when you augment a human and give them superhuman powers, potentially you need fewer humans. I mean, it's not just a dichotomy, it's kind of a paradox. And I've thought of some examples. You're free not to answer my specific examples, but both companies, IBM and Microsoft, are involved in the next generation of call centers. And it seems to me, as a designer, there are two ways you can approach the call center. You can give the call center operator superhuman skills, or you can replace the call center operator. And here, these two IA companies are both working in that context. So it seems like there are deep issues there that I'd like to know how you're thinking about those.
I mean, IBM, and I think more generally, I think that most jobs will be transformed. And so some tasks within jobs will disappear from humans and will go to machines. But I think that overall there will be, big transformation of jobs where humans will focus on some aspects and will not be involved in other aspects that machines can do better. Of course, there can be a transition period where, some occupations will be transformed so much that then people will be have to be reskilled. And that's also where IBM is very committed to help, people in the reskilling phase. So I think that that's where we need to focus, transforming jobs, helping people to be reskilled. And then, again, this is the kind of conversation that has to be done together with economists, sociologists, to find the right solutions to whatever issue can come out. We have seen in the past that in the long run, every very powerful technology has been an issue in terms of, marketplace, but in the long run, then it created jobs. And I'm not convinced that this time is different. So, of course, as to go back to the issue of it's very difficult to invent or to imagine, it's easier to understand which jobs or which tasks are going to disappear, but it's more difficult to imagine new jobs. And so people get focused on the first part and not on the second part because it's not. So if you were telling somebody living at the beginning of the last century, where more than 90% of the people were working in agriculture, we're telling that only 2% of the people in 100 years will be working in the fields. And everybody else will have jobs, but jobs that do not exist right now. And people would have said, what are you saying? Are you crazy? Of course, what are we going to do if you don't work in the fields? And so, so that's the point. I think that, IBM and many other companies, again, are very committed to helping in this transition.
So you guys are talking about this notion of making algorithms transparent and accountable. So, take a Cortana or a Siri, or so many of these algorithms now touch human consumers. It's not like there's something up in the cloud. They're actually, they're giving us advice all of the time. how do you take an algorithm that gives us advice and make it transparent or accountable in a meaningful way to the person who is either the customer or the product, depending on your view? I mean, what can you do to expose in a real way, a conversational system?
Well, I think the question is misleading. You start from, the designer starts from the goal of the design, which is to, in these cases, or those two cases, empower the human to be more effective at certain things. So more effective at communication, more effective at enjoying music, more effective at making a schedule, whatever, or even just more effective at searching the web. And these are things that these assistants are now kind of interface intelligence. They know how to use the technology to do things for you. So there really isn't a conflict yet about, that needs to be like justified, like it wants to do this and you want to do that. I think that'll come in different kinds of products, but at least I think for the folks here on this panel, and some of you mentioned this design-centric framework, designers think about human empowerment first, and then you work back from there. And I think that's PAI has a lot of that, the partnership on AI has a lot of that in its backbone too. Like, we think, how, both individually and collectively, how do we benefit humans with this technology? And it turns out it's not a trade-off, because actually that's why we're building it in the first place. And making money can follow from that, if business models are correct.
So as the guy who's not in a company, I can take a longer view and say that eventually you don't expect explanations or provenance for everything. Part of the way we live our life is we start trusting certain entities, and so in the beginning they have sort of established the provenance of their reasoning. So this actually brings up this issue, and the longer term, I don't actually see AI agents continually explaining themselves. You will have your own personal AI agent that sort of knows your preferences, that knows your value system, and then you have, over a longer term, in a longitudinal interactions, you have developed trust in them, in it, because it has provided in the beginning, the right kinds of explanations that tells you that it's actually using the right kinds of information. And then eventually, for the complex things, you actually, if either you stop trusting the system, in which case you get a different personal AI, or you essentially have come to a point where you sort of tacitly agree that it has a good understanding of what you're looking for. And that actually becomes important, because if you're actually explaining everything, it's an extremely inefficient interaction.
So the right word, I think, is trust.
Trust,
you want
indeed.
to build trust between humans and machines.
Yeah, so why should I trust your AI? I mean,
No, you should trust, because not at the beginning you should not trust.
Exactly.
You should over time
verify.
build trust over time, over repeated interactions and collaborations with this AI, seeing that the AI is helping you, is following your same values, is aligned with you in the values that you want to follow in your behavior. And so then, you will, as Rao says, you will start asking explanations at the beginning, because maybe you don't know exactly where these suggestions are coming from, but then over time you will ask less and less.
But I mean, I can buy that, particularly in, Tom sort of laid out this model, we're selling hardware, we're your friend. But when you're selling advertising, I mean, basically they want to convince you to make decisions. And they're doing it in very subtle ways. This is happening, with something as simple as which Korean barbecue to choose, or which spouse to choose. You're coming in contact with
the same level.
I'm not getting those advertisements for some reason. I don't know why. But
you're coming in contact with, we're surrounded by this soup of algorithms that are giving us guidance. I don't think most of them have this kind of I'm on your side kind of.
No.
So that's not what's going on by and large
but
today.
you fight fire with fire. You don't expect Apple, with all due respect. Apple is a great company, and IBM is a great company too. You don't expect Apple and Google to look after you, okay? You expect your personal AI to look after you. So it's going to be your spouse, your AI spouse or AI twin, which basically understands enough about you that it can say, these kinds of ads last time around, you wound up hating that Korean barbecue, never again go there.
Yeah.
So you need a guardian AI, and I think technology is enough that it's not just Apple which is going to put things out. We are going to have guardian AIs for all of us. Each one of them, John Markov's thing might be very different from mine, and it understands me. And it's like nobody cares about what I think, but my AI does. My dog does, my AI does, and hopefully my spouse does. Right? So that's basically what I'm going to do.
I think that's a great idea, but it looks to me now that the second home robot is really much, it's an Echo-like device. It doesn't do much except carry out your commands, but then you have to look at the motivation of the company that's put it in your house. And so maybe I'm going to need a robot to talk to my robot.
Yeah, I mean, no, in the sense, I have one agent. I mean, the way I think about it right now. In fact, again, some months back, I think in March, at Arizona State University, we had this whole, workshop on essentially envisioning adverse outcomes from AI and figuring out how to deal with them. And one of the big issues was basically the idea that if AI is part of the problem, it's very much a part of the solution. And so, in fact, the way you handle whether or not companies are possibly misleading you is to develop technologies. And in fact, one of the great things about computer science and AI in general, AI also, is that it's very democratic right now. Some of the best work is being done in open domain, and even many companies, both Apple and IBM, et cetera, are supporting that. That's a great thing. And so, in fact, I think we could actually have technologies that will support the little guy, and just with because they're only responsible for that little guy, and they are sort of can help in figuring out some of the. So it could be an arms race. Anything important is going to be an arms race, and you just want a good arm on your side, and that would be your personal AI, in my view. So
what I want a roused dog in the following sense is that I want a marketplace that competes in AIs that can sniff out fake news and stuff like that.
Yeah.
Like that would be something that would be worth a lot of money, and be worth buying. And I think, like you say, it's kind of countermeasures. And in any pattern, anytime you can be good at taking this pattern and manipulating you to go there, you can take something that can recognize a pattern and make it go somewhere else.
Yeah.
So there's nothing, it's value neutral, but the marketplaces can help decide how it gets used.
Yeah. Okay. Are Asimov's 3 laws entirely obsolete at this point? I mean, I don't know if you saw this, but Oren Etzioni, the director of the Allen AI Institute, in the Times, the New York Times, the other day, proposed 3 new laws. And they were kind of. Let me just read them, and I'm going to get you. He proposed that first, an AI system must be subject to the full gamut of laws that apply to its human operator. An AI system must clearly disclose that it is not a human. And finally, an AI system cannot retain or disclose confidential information without explicit approval from the source of that information. Could those be best practices?
So, yeah, but I would add some more. For example, I would add that really the issue of value alignment is very important, and this is, I don't think is included in those 3 laws. So you want to make sure that this AI system that you deploy can be, by design, but also can be adapting themselves to be aligned to the values of the human with which they work. And by observing the human or by designing these values inside, so that is something very important. And then read again the first one.
First, an AI system must be subject to the full gamut of laws.
Yeah, so that it's also debatable. I mean, there are some protocols and ethical guidelines that humans have to follow in every profession, for example. And I don't know, maybe you want to use exactly the same for AI system, but maybe not. Maybe you want to think differently for AI systems. Maybe you want to put a higher bar there, at least at the beginning. So I would not state exactly the same law in terms of.
So it's actually, I think, as somebody pointed out on Twitter the other day, the most important point that people forget about Asimov's 3 laws are most of his stories about how those 3 laws can be violated quite creatively. Yeah. And we humans have this crazy thing about starting from 10 commandments, 3 laws, the 3 laws of Oren Etzioni. These are simplistic solutions in general, because for everyone, if there are 15 laws that we can just live by, we don't need courts, we don't need judges, we don't need precedences, So I think, it seems to me that part of it is we need to be realistic and say that there are no simplistic, 15 or 5 or 3 laws that will just cover everything, and especially because we are our own biggest enemies, human race I'm talking about, because for every law you can come up with, we'll figure out how to find a way, loophole outside of it.
You might need a new set of rules, just to keep this bouncing, a new set of laws for agents, because in some sense they may have a different way of violating or stretching them. But for example, it's legal, in a global sense, not in the US laws, it's possible to make anonymous corporations.
Exactly.
They're kind of like a rogue agent. You can make, and there was a great, TED Prize winner about this. Anonymous corporations are a source of a huge amount of corruption and evil in the world, right? You can hide under them, move, and so it might be that we could make laws that say, we don't want anonymous, empowered AI agents running around making money and spending it. So we just don't want that in our world. We can make laws to try to stop that from happening. You may not be able to put them in the source code of the AI, but you can put it into the legal apparatus in which the humans live in that create the AI. Because that could be very dangerous. If they start trading, making money, they become an anonymous corporation on their own and do all this kind of stuff.
So the other issue is, I think the days of nations with nice borders so that they didn't have to think about other nations are over, right? So even if US decides to have like 15 laws of AI, what happens when other countries don't follow through? And so, in fact, Arun actually makes this interesting point that we can't stop doing AI, just because other people will anyway be doing AI. And yet he falls to this point about maybe these 3 laws. Who are going to ratify these 3 laws? Who are going to make sure? I'm sure that Apple US will follow them. But beyond that, I'm not too sure what happens in the rest of the companies.
To what degree is the partnership international at this point?
Yeah, we have several partners from outside the US, from Europe, from Japan. Sony has joined, for example.
Have any of the major Chinese players joined yet?
So some companies have been talking very seriously, and in fact, there's been interesting discussion on the board as to, clearly given that different societal structures, how do we make sure that, there are common ground for all the partners?
But that's a very big goal for the partnership, to be really inclusive of all the possible cultures, because there is no universal set of values, of course. And so you want to understand what AI ethics can be spelled out to in different cultures and with the different nuances, different ways of relating to robots. Just imagine a robot that you want to deploy in US, Europe, or Japan. People relate to robots in very different ways in these cultures.
Yeah.
So there are lots of nuances, and we are making efforts in connecting to these other cultures and the initiative that they have there around AI and around AI ethics.
I still want to sort of pursue the notion of how you embed ethical decision making into software. Maybe we could talk about it in the car context, bringing up the trolley problem. Is the trolley problem something just for philosophers, or do designers actually have to think about the choices of whether to run over the bicyclist or run over the old lady? I mean, could you see designing systems? I mean, is this going on today in the design of transportation systems?
Apple Car?
Go ahead. I mean, this is such a great topic, but.
I actually want to say it in a slightly different way, which is when I got into the AI grad school to do AI used to be a big tent with philosophers, psychologists, and cognitive scientists being part of it. Somewhere in the middle, we became a pure CS-oriented discipline. But now it's again expanding, because once we start having these bigger impacts, in fact, these things are very much part of the discussion. So we don't have answers, but we are actually thinking about these questions. So for example, Francesca is going to be the program chair for a AAAI ACM conference on AI and ethics and social policy. So these are places where people, hopefully people, not just, a bunch of engineers, but philosophers and cognitive scientists can talk about the issues. As far as the trolley problem is concerned, there have been interesting studies saying people are very happy to talk about this until their life is in question, then say, run the old ladies, run the dogs, everything down, as long as I'm alive. So that's the answer there. So,
Yes.
I think Mercedes made a statement, didn't they, that their cars would protect the driver? I believe they made.
Otherwise, we won't buy it, right? Why would I buy a car that won't protect me? So.
Yeah. But I think more generally about how do you embed these any sort of ethical principles, I think that it has to be a combination of these two, like so-called bottom-up and top-down approach. So top-down approach where you write some rules of behavior But of course, this approach alone is not going to be enough because it's going to not be flexible enough for application, for deployment in the real world. And then the bottom-up approach, when you just observe somebody that you think behaves ethically, and then derive some principles out of that observation. But that also is not alone is not going to be enough because you may miss some very basic, rules. So how to combine these two things is really a challenge, I think, which is, I think, also a challenge in general for AI. How do you combine this kind of rule-based, symbolic-based AI and the more machine learning, data-driven AI?
Yeah. We're getting close to the end, and I wanted to ask you, sort of how these AI systems that collaborate with humans are going to change the nature of human society over the next decade or so. And let me frame it this way. I think a lot about, I think a lot about the movie Her, for example, where an AI system became compelling enough that a human being fell in love with this. I mean, I've reported on experiments in China that Microsoft ran in which 25% of the users typed "I love you" to a chatbot. This is a very large number. This is like 11 million users, 25% of them. So, and we know we're on a fast ramp. I mean, machines are becoming more emotional. What kind of a society would it be in which interacting with a machine is more compelling than interacting with a human? And is that a possibility?
I don't think that's, I think it's already the case. People they sit on the screen all day and they interact. I mean, are they interacting with people or not when they're using Facebook? Who knows? That's a philosophical point. But I mean, the goal, I think, from the design point of view is to augment you with a mirror, not a black one, that, that lets you see yourself in a way that you can't see yourself today. And you can do this, like the simplistic model is this sort of quantified self thing today. What's your blood pressure or whatever. But it gets much more interesting when AI can make sense of that. And that mirror is not just your body and your health and how you're doing with your exercise. It's also maybe your emotional management. It could be a lot of things. There's nothing mystical about emotion compared to other sorts of human activity. It's just a thing that you have to learn about, study, make models of. And so you can imagine, for instance, in the autistic spectrum, there's a bunch of folks who could use some help. Maybe it's a memory. Maybe it's Alzheimer's, and you can just use some help with the memory function. This augmentation is going to change society. It's going to level up these kind of, call them disabilities for lack of a better word. These people where you're not on the cutting edge of these abilities. It could, I think, would make an egalitarian society where things that could be augmented with a cognitive enhancement or an augmentation no longer matter in your ability to compete in society. And it might be more that maybe you will compete in more other things that can't be automated. I don't know I won't name them because maybe there aren't any if some of these people, but that's my model of because I think we don't really look at ourselves very carefully, and our technology has got so much potential to let us see ourselves.
Yeah. Well.
So I actually want to take slightly longer view on your question, which is exactly how this whole enterprise of designing agents that sort of mirror us. How is it going to change the society, and the human society? I mean, some really smart people that I respect a lot, such as Sherry Turkle, have worried about, are we going to lose the essence of humanity, by kind of being so much into typing "I love you" to chatbots? But the reality is, and in fact, some very serious AI researchers have said that there should be a blanket ban on humanoid robots, because juniors can't tell the difference between the real thing and the humanoid robots, and they might start thinking they're humans. The reality is, as you pointed on the Her, there was no actual form. It's just a voice. And humans are extremely good at seeing humans everywhere. Okay, I mean, I come from India where we see every little stone with a slight form as a particular god who is of human form. So the real question is, ultimately, I think there are going to be these issues, but overall, in trying to create these entities, I mean, I kind of think, at least part of the reason I'm in this area is the end of all this exploration is to find out more about ourselves. What is it that actually, what is humanity, to some extent, becomes clearer when you start, dealing with these kinds of agents. And that, to me, is not a AAAI paper idea, but that's one of the things that I feel interested about in working in these kinds of areas.
Yeah. So I'm going to turn to the audience questions, but I want to ask you all one last question. This is a field that has tended to overpromise and underdeliver over a long period of time. There have been a couple of AI winters. There was a winter in the 70s. There was an AI winter here in the Valley in the mid-80s. And here we are. It's clearly a boom. And is it a bubble? Do you guys have an individual sense of how this is going to end? Are we just at the front end of something, or is there going to be a darker period?
Well, I think that if we can handle well, if we can educate well, everybody else, because the hype comes, I think, that from people that really are not aware of the current state of the art in AI. That's why they think that, we can solve everything, but it's not true. There are still a lot of challenges in building, a truly intelligent system. AI, artificial intelligence machines cannot perform common sense reasoning, for example, and that's a very big part of how we reason in an intelligent way. They cannot, so there are many things that they cannot do yet. And we don't know when we will, solve those challenges satisfactorily. So there are a lot of limitations, and so this has to be known. Otherwise, really, this hype will grow and grow and grow, and then people will say, "Oh, why are you not able to do this and that?" But I never told you that AI was able to do that. So that's educational effort is very, very important, I think.
I think if you look at the technical advances in AI, obviously there have been some bigger ones more recent years, but the public perception has really gone exponential. And to some extent, that hasn't really kept up with, I think AI has been progressing quite well over lots of years. There have been some interesting, synergies between the way the internet and, has developed, and we have the data to actually use. But part of as somebody working in AI for 30 years, one of the things that worries me is there was a time when people who talked about AI actually knew something about it. Right now, right now, you do not have to take intro to AI. You do not have to see anything about AI to be an expert in AI.
Yes.
Reed Hastings is an expert, Reid Hoffman is an expert, everybody is an expert. This is just the Reeds I'm talking about. But in general, so what that basically means is that people, essentially, the humans have this thing about example closure. If I show you a particular capability, if I sort of jump, then you think, oh my God, Rav is a basketball player, he can do this, he can do that. Now, if you see, basically a deep neural network seeing that this is a dog, you think it actually understands everything else, but the way they fail, their failure modes are completely incomprehensible to us. They actually can be made to see ostriches everywhere, for example, it turns out, right? And so I understand that humans make mistakes, but we have understandings of humans' failure modes. We don't yet have understanding of AI failure modes. So I find as a huge AI booster myself, I feel worried about tamping down the excitement on the outside because people are just essentially jumping to conclusions and papers don't help. New York Times is a great paper, but the overall media has been quite a bit on AI does this every day. I made a mistake of putting like a Google alert to tell me AI articles. I no longer read New York Times. There's so many articles just to read from there. So,
look, a little froth is fun, and we'll have this for 10 years and make a bunch of money and all that sort of thing while it's happening. But there's one fallacy I want to put the nail in the coffin on. Here's an intelligence ability to do a thing, basically a classification problem. And we're getting very good at classification problems when there's available data. Machines are getting very good at this. And then someone says, well, using that classification problem, you can do something like, I don't know, beat someone at a human game, a closed world game, or look at pictures and recognize things in it. And then the fallacy is, wow, humans do this thing really well. It does it even better than humans at this narrow task based on classification. So therefore, it's going to become generally intelligent like humans are and get better than us. There's not any scrap of logic or evidence that justifies making that leap.
Exactly.
But that's the fallacy that most people go through, and that's where all the fear comes from too.
Yeah.
But the good news is there's a ton of low-hanging fruit in classification and pattern recognition.
Yes.
Yeah.
I mean, every industry, just like there was when the internet happened 20 years ago, right? Wow, you cooked everybody on a common network, and all your business changes. and society changes. What's going to happen with this stuff too? Because now, if your business is recognizing patterns, you can automate it,
Yeah.
right?
No, but I think that what Ralph said is very true. I mean, that the AI research and advancement has not gone, flat and then exponential. It's been going for 50 years, in making, improvements. What has been exponential is the availability of data and of computing power, which at some point passed the threshold to be able to use machine learning algorithm to give AI systems much better perception capability, much better, being able to read, understand an image, read the text, understand what it says, make translations from language to another one, and so on. So, but that has been the exponential growth, which allowed some additional perception capability for AI, but not the breakthrough made in AI and the discoveries on how to make machines more intelligent.
So you're committed to sort of educating the public. Is it possible we're going to see partnership ads on the Super Bowl?
Super Bowl, that's...
Oh, okay, well,
Yeah, I guess
think
if
about
Apple
it.
puts in more money,
Yeah, you bet.
or IBM puts in more money, yes. But I think actually, I mean, I think it's quite important to notice that the improvements have been going on, and then people necessarily outside people don't necessarily. I mean, for example, I'll put you on spot and say you started by saying the only big thing is machine learning, as if intelligence is just learning. There's no use if you learned a lot if you didn't do anything with it, if you didn't reason about me, if you didn't do any action. AI is much richer than just learning. And I think it isn't helping that people, I mean, so there are very few jobs for you because you can see well. You can make your eyes well and see. There are very, very few jobs. And so AI is a lot more than doing perception. It is true that we had trouble doing perception before, but we're doing well. Yeah. But there's so many other things that have to come into the mix before we can actually get to the
also,
next level.
even in learning, AI system can learn, as Tom said, in tasks where there is a lot of amount of data. But once they learn well how to do that task, and you want to use them to do some other task, even similar one, you have to start from scratch with lots of data about the other task. That's not how we learn. Once we learn something for a similar task, we use the concepts in our mind that we put together from that learning task, and we don't have to start from scratch for another task. So we still have to understand how to make AI learn also in that more efficient way. Yeah.
I mean, if it's looking like we're putting down AI, that's not what we are trying to do. I think there are lots of great open problems that are being worked on. Yes. It's a great time to be in AI. Of course, the perceptions, public perceptions are always, they're just very volatile, and we do have to worry about, whether if the bubble might burst, or we could just make the next level of improvements so that we can keep the bubble, hopefully.
Let me ask you some of the audience questions. There's some good questions here. What will happen with advertising when AI is able to tell you exactly the best product for your needs, and then parenthetically, and subsequently to all tech giants that exist due to advertising revenue? Anybody want to take that?
Jan's not here. We can't do that.
Yeah, we can. Yes, right.
Wrong company.
Next panel.
Okay, we'll save this one for the next panel. I am a physician. How will AI replace a job a physician does with empathy, care, and coordination?
It will not. It will not replace a physician. It will just, allow the physician to focus more on empathy and care and these other things, and it will be able to free the physician from many other tasks that the AI can do better, like, making sense of all sorts of data, of literature about a certain disease, of cases. I mean, and think about helping a physician in our culture, our society, our healthcare system. It will help a lot. But think about the developing countries, where there are very few physicians, very few cases, very little access to the literature. That is where really the AI will help a lot.
IBM has some beautiful advertisements about augmented doctors, but I began to think about, if you look at the society as a whole, maybe it might be better to augment physicians' assistants and dispense with doctors. Maybe for the society as a whole, that would actually lower the cost of medicine.
That was a very facile wave of the hand when you dismissed the doctors. I have an example I'd like to use. If we do our job well, we'll put school bus drivers out of work, and we'll take school bus drivers and make them skilled healthcare providers. Because the reason we hired school bus drivers is because we can trust them with our children and trust them to show up at work on time and be honest and caring. That's exactly what you want with a skilled healthcare worker. Yeah. But the school bus drivers shouldn't have to go to medical school to do that job if AI is done right. It should be augmented with the brilliance of the intelligence for doing that.
So I mean, to the person who asked this question, I think there are certain tasks that AI is already currently very good at. I sort of half-jokingly say that mothers, don't let your kids grow up to be radiologists, because AI is going to do X-ray reading much better than humans at some point of time. But on the other hand, the whole part of this panel is essentially how do AI systems interact with humans, and that is something the field hasn't given as much emphasis to. So I think you will still, at this point at least, we will need people in the mix. And at some point of time, I would like my AI systems to have the ability to understand, how to talk and what is the best way to, interact and with empathy and so on. But that's still farther away. So I think,
So Francesca, you touched on this, but it's asked again. So how do you reconcile the fact that humans can learn from a very small scale of input, yet the current AI systems require large scale input? That is, child development versus machine learning. How can this be bridged in the model? Do we have any good ideas?
We have to understand how to do that better. Maybe we can do that in a very narrow, tasks and scenarios, but in general, I don't think that we understand that, and that's definitely something needed.
So that's actually, given that Ed is here, John McCarthy's original idea was to have an advice taker program, which, as a teacher, I hate to have to give 10,000 million examples to my students so that they will learn from those patterns. I hope that I can just say a few things and they can learn from that. Mm-hmm. And that advice taker is still a bit of a dream. With all the great strides we have made in database learning, the other aspect, which is how to take a piece of advice and then a single piece of advice and then essentially convert it into your knowledge. Part of the reason for that, part of the problem there winds up being essentially learning in the context of background knowledge. Most learning systems till now are reasonably sort of starting all over again for new tasks. There is some ideas like transfer learning, but they're still primitive. So I think that's a great, that's one of the things, in addition to common sense, learning from few examples is one of the things that I keep saying as a next great breakthrough that has to happen in AI before you will start actually using your assistants. Either they can learn from simple behaviors over millions of traces, or you would like to just tell them, I don't like to do it this way. And then they should be able to essentially understand how to convert that into their knowledge base. And that is something that's a big research problem right now.
So here's for your science fiction fans out there. What will be early warning signs that machines are getting close to having human-level general intelligence? What do we have to keep our eyes open to detect?
I think we are always thinking that it's already happened. Basically, we tend to sort of attribute a lot more intelligence to machines than what normally they have. So I think we will keep thinking that they have a lot more intelligence than they really have. And when they actually become as intelligent as us, it won't be like a huge difference, because we've always been delusional, thinking that everything, including thermos flask, is
it's a mushy question. I want to stop this. What is general intelligence?
Yeah,
define it.
know.
Because
and definitely, I don't
25% of people think that agent that they're chatting at is something worth loving. What do we mean when we think something is intelligent? We don't know.
Yeah.
So I think it's not going to be, there isn't like this jump to AGI.
Yeah.
That's just
so we will not wake up one day and discovering that there is some AGI, general intelligence that was developed. I think that we will, make machines more and more useful and intelligence in a very narrow domain. already they are, in some narrow domain, not more intelligent, but more capable than us to solve that narrow thing. And we will have more and more of that, but I think, I don't even know if we'll ever get to a general intelligence.
And this is, this may be more about us, right? You pointed out that we anthropomorphize everything. So as a new reporter at the New York Times, I think in 1990, I covered the first sort of formal Turing test. And there were two sets of judges. There were some computer scientists, and then they grabbed some people off the street. And I have to tell you, for the people they picked off the street, the Turing test was passed in 1990.
Exactly.
And, which I think says a lot. Let me go on to this. To the panel. Our children will inherit a world that does not yet exist. How can we best prepare them as parents and educators for the future?
Plastics. Well, polymers, okay, it's modern.
I think there was some discussion, for example, about employment, et cetera, and there's some interesting studies that have been done to show, for example, that the kinds of professions that are most likely easily replaceable are not just blue-collar jobs, are not just white-collar jobs, but it is essentially routine, either blue or white-collar jobs. And if, so tell children, don't depend on doing something routinely every day, even if you get paid a humongous amount of money for a couple of days, because I show this to my students that if that's the kind of job you have, robots will take it over, so find something else. So I think we are here to actually be creative. Even people who go to 9-to-5 jobs and do mind-numbingly routine work are extremely creative when they come home. So hopefully all of us will be essentially doing work that's creative, because the routine work will be easily replaced by, humans will be replaced by that. And I think that's a good thing to some extent. So,
how does AI account for instinct?
Instinct?
Instinct.
Well, sorry, go ahead.
Well, I'll pretend to be a token psychologist again. So, instinct is like the spirits in the trees, being God. What is it? And instinct is the thing we say when we don't know what it is. It's this motive for behavior that we don't know what it is, so we call it instinct. The more the scientists work at animals that are supposedly full of insects or whatever, that they're just driven by instinct, then they find these principles, and it's not really instinct. So I think it's a mystical boundary that keeps getting pushed out. I think there are, though, I want to encourage people to not be cynical about these things like insight, human ingenuity, emotional intelligence. These kinds of intelligence are fully within the range of AI, just like anything else.
Exactly.
It's a matter of, do you have the data? Do you have the ability to recognize the phenomenon? Can you build, I think, as Feigenbaum was basically saying, can you build models, psychological models, that are implementable of human cognition? And if you can, then you can automate it.
It was also partly because of it's also a lack of will in the AI research community. I tend to say that emotional and social intelligence was the Rodney Dangerfield of the intelligences. There are enough old people who might understand this reference. That basically it was seen as something that psychologists do, not computer scientists. And it's becoming much more important that we have to be able to do that. But I want to mention something about this instinct part. It's been said, I think Andrew Ng said, that AI currently can do everything that humans can do within a couple of seconds. And things that we do in a couple of seconds are basically instinctive. So in some sense, you jump to a conclusion. If that's all we had to do, then we don't have to reason, we don't have to provide explanations and so on. Yeah. So in fact, I think most learning systems that learn patterns that you don't yourself understand are probably essentially are examples of instinctive leaps of faith. I don't know how many of people have heard of this whole Polanyi's paradox. Polanyi basically talked about the fact that there's a lot of tacit knowledge. And I think in some sense, strangely enough, the early parts of AI depended on people telling computers what they already know. The current swing is machines learning about things that we don't know how we do. We don't know how we do vision. We don't know how we do speech recognition. And we don't know actually how we hold things. And those are things that we can't actually program computers. They're better learned themselves. But there are enough things that we also understand. There's a whole civilization. And that basically we want the interplay of both the tacit and explicit knowledge. And in some sense, I think actually the pendulum has swung too much to the point where people think intelligence is just tacit knowledge and instinctive reasoning.
So
And
this
that would be a very sad life.
This is, somewhere related to the system 1 and system 2,
Exactly.
defined by the, Cunningham. And the idea that system 1 is when we use just our instinct to make very fast decisions, and when we need some more computing power, then we resort to system 2. So in some sense, as Rouse said, traditional AI has been mostly about system 2 kind of capabilities, reasoning, inference, and so on. And like these, machine learning, observation thing are more like, developing the system 1 of AI. So the point now that we need to understand is how to make these two systems collaborate with each other in AI systems as well, like we do
And I think
in
in
our
human
brain.
intelligence, this happens. I mean, if you talk to the top mathematicians, they say that they came to the insight about how they did a proof in while taking bath. Normally, apparently, that's when these things happen. But then you can't write a journal paper saying, I got this, this thing. You actually have to reason out and say why the proof is non-fallacious. And we are very impressed with systems because the systems are 98% good, or 95% good in predicting your sexuality or your criminality. And in fact, this morning, I told my students that I'm going to use AI to predict their grades too, just from their faces. It's like AI using, I can reduce my work and AI will do the AI grades and so on. But that's part of it is because we are I think there's a pendulum swing towards instinct is everything. I think to me, the apotheosis of human civilization is that we went beyond instinct. We actually reason about things that we probably reached by instinct. And AI first part of AI really was about that. The second part of AI is this. And the beautiful research that all of us are looking forward to is actually the symbiosis of both.
I just want to recommend, if you want to pursue Polanyi's paradox, David Autor, A-U-T-O-R, MIT labor economist, has written a wonderful paper called "Why Are There Still So Many Jobs?" and I think he's really one of the better thinkers on the question of the limits. Let me make this the final question. I think, Francesca, you and maybe you've gone to computer science meetings in Asilomar. And they were sort of modeled on something that happened in the molecular biology community in the 1970s, where that community went to Asilomar and they famously stopped research for a while. And they may be back there soon, but that's another question. But the question is, molecular biologists famously forswore certain kinds of experiments. Are there certain kinds of AI research that should similarly be off limits? Is there anything now that...
Well, at Asilomar, actually, we discussed a lot about these and many other things. It was a very multidisciplinary group of people, and we discussed about some principles along which AI should be developed and used and deployed. We discussed more than 100 principles, and then at the end of the meeting, we decided to sign, 23 of them that were unanimously chosen by the participants of this meeting. And so they give an idea of what not just AI researchers, but also people from other communities, sociologists, psychologists, philosophers, economists, think about how AI should be done in order to be beneficial for as many people as possible. And so that was the overall, I think, goal, besides the discussion and the interaction of that meeting. Come out with a set of principles that we can all agree, and then we can spell out more precisely in our own job every day, in our own company and so on, but by which, AI should be done. And some other kind of principles came out also from the partnership on AI. We have 10 tenets that every partner that wants to join should sign, and agree to those tenets that also spell out our main idea of what AI should be.
Are those different than the pillars, or are those...
The pillars, the pillars are the themes that we are going to follow in our discussion and work. The 10 tenets are, our own principles that every partner that wants to join has to sign.
And the tenets are on the website?
Yeah,
Yes.
yeah.
Okay, well, let's end there. I wanted to say that this evening has been produced in collaboration with the partnership. I wanted to have the audience thank the panelists and make sure you go to their website. Thank you, everybody.
Thank you.